Tor gets branded as the dark web, but that's the loud, messy version everyone argues about. It literally grew out of US Naval Research Lab's onion routing research, and its most common use pushes traffic out through exit nodes, which are gateways back to the normal internet. And gateways create baggage, like choke points, drama, and a layer where traffic becomes visible to whichever feds operate that exit. So what if the cooler dark web story isn't about escaping the regular internet at all, but staying inside a private ecosystem where the exits aren't the main character? That's what we're unpacking today. What people get wrong, why this quieter network feels different, and the trade-offs nobody tells you. Welcome back, nerds. I'm Addie. I've spent 15 years in cybersecurity, and I break down cyber threats before they blindside you. Let's get into it. The lie. Dark web equals Tor. You're about to realize you've been using the right words for the wrong thing. The dark web isn't Tor, and the fact that most cybersecurity people think it is a problem. But here's my confession. I thought this too, like confidently. Then a few weeks ago, some commenters asked me my thoughts on I2P. I got curious, then a little overwhelmed, and then totally obsessed. And yeah, I've been down the rabbit hole ever since. Let's rehash. Surface web, deep web, and dark web are categories of content. Surface web is the stuff search engines index. So if Google can find it, it's the surface web. The deep web is the stuff that exists but isn't indexed, like your bank portal, inbox, paid courses, internal dashboards, you know, the normal, boring, everywhere stuff that's the majority of the internet. And last, the elusive dark web, which is content that's intentionally hidden and requires special software or configuration to reach. So where does Tor fit into this? Tor is software, a network, and a way to route traffic. It can access dark web content, sure, but it's not the definition of the dark web. And once you stop treating Tor like the entire map, you'll notice the other half sitting there like, hi, I exist. That other half is I2P. It stands for Invisible Internet Project, and it's an anonymous overlay network, meaning it runs on top of the internet like a private layer. Instead of being mainly about visiting the regular web anonymously, it's built to host and use services inside the network. So who's this actually for? This is for people who want privacy for normal reasons, like hosting a site without tying it to a location, building communities that don't revolve around big platforms, doing peer-to-peer communication with less reliance on exit points, or learning how anonymity networks actually work instead of repeating internet myths. If your goal is private services inside a private network, I2P belongs on your radar. Here's the thing I wish someone told me earlier. Tor was designed primarily to anonymize access to the regular internet, and I2P was designed to build a private internet inside the internet. They have totally different goals, architecture, and assumptions. Pretty much everything is different. If you've only ever thought about dark web and anonymity through Tor, you've only been looking at half the map. And once you understand how I2P routes traffic, you'll realize why it changes the threat model entirely. So what happens when onion routing isn't the main character anymore? Onion routing versus garlic routing. Tor uses onion routing, which means layered encryption through one circuit where traffic goes through a path and the layers peel back as it moves, like an onion or an ogre. It's a pretty clean mental model that's easy to explain and misunderstand. I2P, on the other hand, uses garlic routing. So picture bundling multiple encrypted messages together like cloves in a bulb. Instead of sending one neat little packet down a single path, you can bundle multiple payloads together, which make patterns harder to read. Now, here's the structural twist that makes analysts sweat just a little bit. Tor typically builds bidirectional circuits, which means one route handles both directions. I2P builds unidirectional tunnels, so you use one set of tunnels for inbound traffic and a totally separate set for outbound traffic. And those tunnels are short-lived, rotating way more often. So if you had to guess, which architecture leaks more metadata about directionality? Most people guess wrong because they think 2 tunnels equals twice the leak, but splitting inbound and outbound forces an observer to do more work to stitch the story together. Correlation gets messier, the picture gets more chaotic, and when you're predicting anonymity, chaos is a feature. One more key difference. Tor is famous for helping you reach the regular internet anonymously, which is why exit nodes matter so much. I2P doesn't focus on exits by default. It's optimized for internal anonymous services, like things that live inside the network. So routing alone already sets the tone. Tor leans towards anonymous access outward, and I2P leans toward anonymous life inward. But routing isn't what makes I2P feel like a different species. It's how it handles identity. So what does identity even mean when the network stops caring about IP addresses, destinations, lease sets, and NetDB? In I2P, the big mental shift is simple. You don't chase IP addresses, you aim at a destination. And a destination acts like an identity card made of cryptography, you know, my favorite. Basically, a public key that says, this is who I'm trying to reach. So the question stops being, where is the server, and becomes, how do I reach this identity inside the network? Hopefully this part makes it click. To talk to that destination, you need a doorway. That doorway info gets published in something called a lease set. A lease set is just a small bundle that says, if you want to reach me, use these inbound tunnel entry points. That's it. It doesn't expose the whole route or hand out a street address, but instead it gives you approved entry doors, and those doors expire and rotate. So where do lease sets live? Inside the network shared directory called NetDB. Think of it like a distributed who's reachable and how map that the network maintains together. It doesn't have any central directory authority or single master list. The network spreads and looks up these entries across many routers. Some routers take on extra responsibility helping store and share the directory information. People call them flood-fill routers. Their job is boring but totally essential. Keep the math available so lookups keep working. And here's the part beginners miss. Your experience of the network depends on the peers you connect to. Peer selection shapes what you see and how hard you are to analyze. Participation in routing is part of the anonymity model. So now you've got this clean chain. Destination equals who you want. Lease set equals the doors you knock on. NetDB equals where the network keeps the map. And if that map matters, you already know the next question. What happens if someone floods the network with fake routers and tries to bend what you can discover in the NetDB? Threat models. What I2P protects and what it doesn't. I2P shines when you use it the way it was built to be used. Internal anonymous services, like hosting EAP sites, peer-to-peer communication, and sharing inside the overlay. Even email inside the network if you're using the tools designed for that ecosystem. It doesn't revolve around exit nodes because it doesn't need escape hatches to be useful. That design choice changes who gets protected best. When you mostly live inside the network, you avoid a whole category of chaos that comes with pushing traffic out to the open internet. So it's less dependency on exits, which means fewer obvious choke points and fewer everyone funnels through these places type dynamics. This is something you need to understand. I2P does not make you invisible, just like Tor. Network level monitoring still matters, and traffic correlation still exists as a concept. If an adversary can watch enough of the network, they can play pattern matching games. And if someone pulls a Sybil move, which means flooding the network with fake participants, your peer selection becomes the battlefield. Then there's the human layer, where most people faceplant, much like on Tor. Misconfiguration wrecks anonymity, and browser fingerprinting still tags you like a neon jersey if you let it. OPSEC mistakes still connect dots you didn't even realize you dropped. And yes, the router footprint and environment matter because systems leak signals in more ways than one. So here's the mindset shift. Stop asking, is I2P safe, and start asking, safe from who, with what power, watching which parts of the network. Because anonymity is statistical, but never magic. And that's the hinge point where I2P and Tor diverge in who they protect best. So when would you actually choose one over the other? EAP sites, internal services, and the self-contained darknet. The dark web can be a whole neighborhood. In I2P, the main attraction lives inside the network. That's where EAP sites come in, or internal websites and services that exist on the overlay itself. You don't exit to use them, instead you stay inside the ecosystem. And that changes the entire energy, because the moment you stop relying on exit nodes as the default, you stop building your habits around needing a gateway to the normal web. Instead, you build services that assume privacy is the baseline, like messaging, hosting, file sharing, community boards, and tools. You know, the stuff that behaves like a parallel little internet with its own rules. This is why the architecture matters so much. I2P optimizes for internal anonymous services from the ground up. You can feel it in the design choices like tunnels, identity, discovery, the whole system. Tor can do hidden services too, and they're pretty legit. But culturally and practically, a lot of Tor usage still revolves around breaching the clearnet anonymously, in air quotes, which pulls traffic patterns towards exits and creates a different set of hotspots. If you remove the exit nodes entirely from Tor, what would happen to how most people use it? I'll give you a second to think about it. You'd watch a huge chunk of anonymous browsing behavior evaporate because the demand shape changes the network. And that's a philosophical split. One network often acts like a privacy layer on top of the existing web, and the other leans towards building a self-contained world where the web lives inside the anonymity. And that self-contained idea feels powerful. It also comes with a trade-off. The more self-contained a network gets, the more the details of participation, peer selection, and operational habits start to matter. So what's a safe way to think about all of this, the safer way to think about the dark web? If you want a clean mental model that keeps you smart instead of paranoid, start here. Architecture shapes privacy and usage shapes risk. The dark web isn't one place with one vibe. It's a bunch of intentionally hidden networks and services, and the tool you use doesn't automatically explain what you're doing, why you're doing it, or what you're exposed to. First, what's my threat model? Who do you want privacy from, and what power do they have? Is it a local network or an ISP, a targeted adversary, or broad monitoring? Your answer changes everything. Second, am I accessing the regular internet anonymously or staying internal? Those are different journeys with different metadata footprints. Third, am I consuming content or hosting a service? Hosting changes your exposure, your uptime needs, and the kinds of mistakes that hurt you. Fourth, what metadata leaks in this architecture? Is it directionality, timing, peer selection, identifiers, browser signals? The boring stuff that quietly matters more than the dramatic stuff. Fifth, what's my operational discipline? Because misconfiguration and sloppy habits torch anonymity faster than anything else. Tools are tools. They can support privacy, but they can't replace thinking. When you understand the system, you start making choices on purpose. So if I2P was built to solve problems, toward it, and prioritize, what comes next when newer networks start fighting metadata even harder? If you enjoyed this video about the other dark web, you'll love learning all about the other stuff nobody tells you about Tor. I'll see you in that video next.